Hello everyone, welcome to my talk for the Azure Advent Calendar. I've got my cup of tea and I'm ready to talk to you about Azure Data Lake. It's a great product built on Azure Storage with a lot of great security features that we use to build up secure data architectures for our clients. Hope you enjoy! At Engine, we work with a lot of companies who work with sensitive data. Because of this, we have to be sure that the architectures we produce are secure. To do this, we've built up a list of best practices and techniques to ensure the security of the data. These techniques are based on standard security practices and the huge wealth of Azure security services. A lot of our solutions are based around Azure Data Lake. Azure Data Lake is based on blob storage, which is Azure's solution for unstructured data. You can store any kind of data in multiple containers. If you upgrade your storage account from a standard storage account to an Azure Data Lake, you retain the queues, tables and files, but hierarchical namespace is enabled on your blob storage. So why do we use ADLS? There are many benefits of using Azure Data Lake. It is built in Azure Storage, which means we can take advantage of all the existing features while adding extra value. It is also performant, scalable, reliable, has advanced security features, and is interoperable in many ways. All of this while being one of the cheapest storage options available in Azure. Being built on Azure Storage means we can take advantage of all the inbuilt security features in the platform. These are mainly centered around Azure Active Directory and role-based access control. RBAC allows us to build up customizable roles and implement a claim-based model for data access. Azure Storage also has a well-defined SDK. It handles all the buffering of read and writes for you, and the new version can also be used with Azure Data Lake. There are some limits in what this SDK can do around the features which are specific to ADLS. These include the controlling of access control lists and atomic transactions. However, there is a new SDK which is currently in preview, which does allow you to take advantage of these features. These SDKs are secured via Azure Active Directory and the claim-based model I already discussed. Azure Storage is a really low-cost solution for storing your data. It also includes lifecycle management, which means you can move your data between hot and cold storage as the access needs for the data change. This means that ADLS is also a very cost-effective way of storing your data, despite the raised cost in enabling the extra features. Being built on Azure Storage also lets us take advantage of the inbuilt geo-redundancy features of blob storage. This increases the reliability of your data. Finally, being built with Azure Storage allows us to take advantage of Azure Threat Detection. Using Azure Threat Detection, we can get alerted of security threats and vulnerabilities as and when they arrive. There are also additional performance benefits for using Azure Data Lake over Azure Storage. I've already mentioned that one of the main differences between Azure Data Lake and Azure Storage is the enabling of hierarchical namespaces. This allows you to organize your data into a file-like structure, which allows you to query over pre-organized data. We'll go over to the Azure portal for a demo so we can see how to set up an Azure Data Lake. You create an Azure Data Lake using a normal storage account. We enter all the normal settings like name and location. And finally, we pick between hot and cold storage. To change from a normal storage account to an Azure Data Lake, we enable hierarchical namespaces. It is also good practice to tag our resources, especially ones that need to be deleted, to enable for easy management of our resources. Alongside the geo-redundancy features already mentioned, there are several features of ADLS which increase the reliability of your data. In many systems, we need to protect against failure due to partial file writes propagating through the system. In many cases, this is done by creating a new file, starting to write to this file, and once the file is complete, renaming it to indicate that it is ready. ADLS supports atomic rename, which means that we can safely and quickly achieve the transactions needed to support this. This means that we can achieve protection against this type of failure. Scalability is also a massive advantage of using ADLS. Currently, there are storage limits of 2 petabytes in the US and Europe and 500 petabytes in most other regions. However, there was an announcement at Ignite recently that we will soon be able to chain storage accounts together. This means that storage scalability will be effectively unlimited, as we can just keep chaining more storage accounts. Spark and Hive and other big data analytics clusters are increasingly relying on linear scaling. This means to add more nodes in order to speed up processing. Elastic scaling in blob storage doesn't limit the data access, and therefore multiple nodes can access at once, meaning that blob storage and therefore ADLS support this linear scaling model. Not only this, but hierarchical namespace means that we can achieve greater data isolation and therefore further increase the parallelization of our processing. I've already mentioned that a large part of the solutions we build is based around security. There are several features of Azure Data Lake which help us build up these secure solutions. Azure Active Directory is the identity management platform which is integrated into Azure. It allows for management and control over identity in the vast majority of Azure services. I've already mentioned role-based access control, but ADLS has some extra features which help to increase the security of our solutions. The main one of these is access control lists. This allows you to control access at a file or folder level and provides a fine-grained security access model, but more on this later. It's worth mentioning that if a user has both roles-based and access control list permissions, the RBAC roles will override the access control lists. There is a new feature which is currently in preview where we can create SAS tokens from AAD credentials. Previously, these could only be created from account keys, and though you could control them at a folder level, the only way to revoke access is to regenerate the account keys. This allows us to create SAS tokens from the credentials themselves, meaning that we can have role-based access control via SAS tokens. All of our data is encrypted by default, both at rest and in transit in Azure. The fact that these services are built in means that the latest encryption techniques can be used, and these technologies can be updated as new tech becomes available. Finally, all changes to a data lake and all access is fully audited, which means we can monitor and control access easily. This, combined with Azure Threat Detection, gives us incredible insight into the access of our data. In terms of interoperability, I have already said that there's a common SDK with Azure Storage. This means that it opens up integration options with any solution which is integrated with Azure Storage by default. So, a hierarchical namespace also allows for interoperability in that Spark, Hive, and other analytics frameworks work with standardized folder structure in order to quickly query data. For example, Spark uses a predefined date structure, for example, like years, months, to quickly search over data partitioned. This means that these analytics frameworks can perform performant queries over our data. Finally, there is the option of integrating with Event Grid. This feature is in preview, but there is an option to natively send our change logs into Event Grid. These can then be routed to other subscribers, and therefore we can then perform complex analytics over these logs. I've already highlighted that Azure Data Lake is built on the cheap storage offered by Azure Storage. It also allows for a choice between hot, cold, and archive storage, which enables further cost savings on older data. There is a higher cost when enabling the ADLS-specific features, however it remains a powerful and cheap secure data storage option. We're now going to move on to specific techniques and technologies we employ when constructing these solutions. Here are the main components. The principle of least privilege means to reduce access as much as possible to any data. Any specific app or service should have access only to the specific data it needs to do its job. This extends to human users, perhaps even more critically, because each human user that has access to the actual data poses a security risk. Identity is a massive component to consider when building a secure architecture. This allows us to know who or what is trying to access our data. Azure Active Directory is the identity management system which is built into Azure. Each user is assigned a user principal and each service a service principal. A specific flavour of service principals is a managed identity. A managed identity is an identity which is linked specifically to the service. This means that all credential management is done for you by Azure Active Directory, which reduces the need to store credentials as part of your application. I've mentioned access control lists already, but there's a feature which is specific to ADLS. They enable POSIX-style security, which means that the access control is saved on the item itself. This allows for fine-grained permissions at a file or folder level. Access control users or groups can be added to these access control lists. If you control access via a group, it means that access can be added or removed to a user purely by adding or removing the user from that group. This allows you to, for example, have a developers group where developers have access to development data, and adding or removing a person from the team is as simple as adding or removing them from that group. Permissions given by access control lists are not automatically inherited. By this I mean that if you have a parent folder and you set an access control list on that parent folder, this is not automatically inherited by children of that folder. It can be set up so that when you create a new child for a parent folder, this will inherit the permissions. So if you set a default flag when adding a permission to a parent folder, this will automatically be added to any new children which are added to that parent folder. This is also another good argument for using groups. This is because because these permissions aren't retrospectively added to all existing children of the folder, this means that if you need to give someone access to all of the data within a folder structure, you have to individually go and add them to every single access control list in that structure. If you use groups instead, then you can set up a group when the parent folder is first created, which will have the access it needs. Then you can add new users to that access group in order to give them the access they require. Finally, it's worth mentioning that in order to enumerate and therefore read any data within the folder structure, you need execute permissions the whole way down the folder structure. We'll now go over to the portal to see some of this in action. If we create a new folder with a child folder, and then go and manage permissions on that parent folder. If we add a managed identity in these access control lists, we can then apply permissions at the folder level. Default means that any permissions added to this parent will be added to any new children added to that folder. We can see that these permissions have not been added to the existing child. But if we create a new child, these permissions will pass through. The next step in securing your data via these access control lists is to consider your data taxonomy. A well-defined data taxonomy allows you to organise and manage your data, as well as isolate it as necessary. This isolation gives greater access control, as it means that services can be limited to just the data they require. But it also opens up governance possibilities. This is around ensuring that regulations around isolation can be easily met and evidenced. The final part of the puzzle is around monitoring and auditing. Azure Threat Detection allows us to detect a huge variety of threats. We can also raise alerts based on these threats, which can be around location, anonymous access, data transfer, deletion, and much more. Alerting on these threats means that we can identify and mitigate risks as and when they occur. So how does this all fit together? A lot of the time when we build up our architectures around data processing, we use Azure Functions. These connect to Azure Active Directory, which then combines with the security features in Azure Data Lake to build up a secure processing solution. Azure Functions are a serverless offering which are capable of doing complex data processing. Combining serverless principles with the pay-as-you-go pricing model available in the consumption plan means that you can efficiently, cheaply, and reactively process vast amounts of data. But that is the subject of another video. These functions connect using a managed identity, which removes the need for you to store and manage credentials within your application. Azure Functions use EasyAuth to secure the HTTP endpoints. For this to work, we have an Azure Active Directory application, which is used to secure it. Any users who want to be able to access the function need to be added as users of that application. There is also the option when connecting to ADLS to pass through the user credentials of the user which is using the function app. This means that the authentication to ADLS will be done using the user's own credentials. Generally, we advocate to use managed identities and to authenticate as the Functions app. This is because this reduces the amount of users which need access to the actual data. Not only this, but if we have the user authenticate to the function app and then the function manage the authentication to ADLS, this separates the two concerns and allows a lot more flexibility when controlling access to the data. Azure Active Directory manages all the identities. It provides role-based access control, and using managed identities removes the need for credential management. The final component is Azure Data Lake, which provides fine-grained access via access control lists and AAD groups, alongside a well-defined data taxonomy. Using all this means that services are given access only to the data they require. Finally, we can detect abnormal access using Azure Threat Detection. Overall, we have a fully secure data architecture which can be used to process large quantities of data. So, bringing all this together. Here I have a function which reads data from a blob storage account. It is using the new blob storage SDK and the new Azure Identity pieces. This default Azure credential will try to get an access token in a few different ways. It will first try using the environment variables, then using a managed identity, and then via a shared access signature. Finally, it will try via an interactive browser. Interactive browser authentication needs to be specifically enabled by the default Azure credential options. I'm using it here to authenticate when running locally. The function then retrieves a blob storage client using the credentials and downloads the file contents to a stream. When running in the cloud, it will automatically authenticate via the function's managed identity. If we go over to the data lake, we can see that the function has execute permissions all the way down the folder structure, including at the file system level. This means that the function will be able to enumerate these folders. For the sample1 folder, the function has default and read permissions, meaning that any new files added to the folder, the function will be able to read. However, it does not have read access to those in the sample2 folder, meaning it will not be able to read these files. If I hit the function endpoint, we can see that hitting the sample1 folder, we will get the contents of the file returned. However, if we try the sample2 folder, we will get an internal server error. It would be better to set up proper error handling to handle the not authorized error within the function, but I've left it out here for the purposes of simplicity. Thanks for listening. I hope you've enjoyed my contribution to Azure Advent Calendar, and that it's given us some insight into building a secure architecture based around Azure Data Lake. If you want to know more, go check out my blog!